My name is Marty McNeil and I'm a marine scientist at Queensland University of Technology, and I'm studying a very special type of reef sediment made of calcium carbonate, but this reef sediment doesn't originate from coral reefs, so it's special because it's actually derived from a very humble little green algae called Halimeda. And this green algae has a calcium carbonate skeleton which grows in segments quite prolifically, and as it dies off, the little calcium carbonate segments that are like little white cornflakes become very important reef sediments in the Great Barrier Reef. What's really intriguing to me is that we've got these two reef habitats side by side, one being the shallow coral reefs that we know so much about and are really well studied, and the other being the Halimeda bioherms, which we just really don't know a lot about at all. There must be some relationship there, and I'm really interested in finding out what that might be. We know that they are the largest living, currently growing and accreting Halimeda bioherm structures globally. Previously, the estimate was that they cover about 2,000 square kilometres in the Great Barrier Reef Marine Park. We mapped just over 6,000 square kilometres. We were mapping the seafloor using high-resolution multi-beam and LiDAR, which is an airborne laser technique to map the topography of the seafloor. What really surprised us was the shapes that we saw on the seafloor topography, sort of 250 metres across each shape, each ring, and that these rings coalesce to form huge bioherms that are kilometres across in extent. The raft of questions is almost endless, because once we saw these new shapes that were completely unknown, we had to reassess and rethink everything that we think about carbonate sedimentology on the Great Barrier Reef. We're talking about a time span covering at least the last 10,000 years. So that's a lot of geological history locked up in those cores, and of specific interest to us is the chemistry that's locked up in the calcium carbonate sediments in those cores. We need to really quantify that. We need to quantify the amount of carbon and carbonate that is being stored by the Halimeda bioherms, not just in terms of their importance for the Great Barrier Reef, but also globally. We know that there's sea cucumbers, sea urchins, marine snails, there'll be benthic worms down there, there'll possibly be soft corals, ascidians, there'll be a whole raft of other organisms that are utilising the Halimeda bioherms as their habitat. What we don't yet know is what role might the Halimeda bioherms play into the future as the ocean warms and conditions become less hospitable and more hostile on the shallow coral reef. You can't manage what you don't measure. So currently, as far as we're aware, there's no continual program of long-term monitoring specifically of the Halimeda bioherms. Our aspiration is to do a high-resolution, intensive survey across the Halimeda bioherms, so right adjacent to the coral reefs, the connecting passages between the reefs, the canyons off the deep shelf that feed up into the Great Barrier Reef Lagoon. Really, it's a multidisciplinary team that we need to bring together to be able to answer some of these complex questions. And this will provide globally significant baseline new knowledge to these processes, not just for the Great Barrier Reef, but potentially in other continental shelf settings as well.